Good. So in this question here, so you can say here in this question we are being told that a laser beam has a power of 350 megawatts. The light from the laser has a wavelength of 640 nanometers. Determine the number of photons emitted by the laser in time of 1 second. So we are given the laser beam. What we are given here, first of all we need to write down what we are given is that power of laser, which is 350 megawatts, which is going to be 350, let us change it to what, times 10 power negative 3 watts. Okay. The second thing we are given here, you can see we are given the wavelength. That is now the wavelength. That's the wavelength of light, which is 640 nanometers, which is going to be 640 times 10 power negative 9 meters. Okay. Then another thing we are given there, you can see time. Okay, that's 1 second. So we are going to be given time that is t equals to 1 second. So the first thing what we need here to do is to calculate the energy of 1 photon using the formula, calculating the energy of 1 photon. Now to calculate the energy, of 1 photon, the energy of 1 photon, whereby we know so that energy equals to Planck's constant times speed over lambda. That's not the distance. So don't forget that h here stands for Planck's constant, c stands for the speed of light, and then l here stands for the wavelength, the distance wavelength. Okay. So for us to calculate this one here, it will be Planck's constant at 6.626 times 10 power negative 34. Okay. Times that the speed, which is 3 times 10 power 8 over, that's the wavelength, which is going to be 640 times 10 power negative 9. Okay, which is going to be, when you multiply this one here, you get that is 6.2626 times 3. 6.626 times 3. We get that is 19,878 times negative 34 plus 8, because remember this is the, when you multiply the indices here, when you multiply the indices, it's negative 34 plus 8, we get this power 10 power negative 26 over 640 times 10 power negative 9. Okay, here it will be what, when you multiply that one, this one divided by that one, you get 0.03 3106 times 10. Now this is division here. You see 10 power negative 26 minus minus. That is now negative 26 plus, because negative negativity gives you plus, you get negative 17, okay? Which is the same as now 3.106 times 10 power negative 19 joules. Okay, that's now the energy of one photon. So after calculating the energy of one photon, the next thing we need to do is to determine the number of photons emitted by the laser in 1 second. Okay, now let us determine the number of photons, because already we have calculated the energy of photons, the energy of one photon. Now let us calculate the number of photons emitted by the laser in a time of 1 second. Okay, now for us to calculate the number of photons, we are going to use this formula, whereby we know so well that number of photons is equal to power times time over energy of one photon. That's power, that's number of photons equals to power times time over the energy of one photon. So at this point here, to calculate the number of photons, it will be the power we are given, power, that's the power of the lens, a laser beam, that is 350 times 10 power negative 3 times 1 second. Remember, we are given 1 second over the energy of one photon. The energy of photons, one photon, that is 3.106 times 10 power negative 19. This is what? This is joules and this is second. So from here, you know so well, when we calculate this one here, it will be so you take now we get the answer to be 1.12685 times 10 power negative 18. Okay, so the answer it will be 1.127 times 10 power negative